Welcome to Science Access. In today's class, I'm going to be talking about how to resolve or how to get the resultant of more than two odd vectors. For example, you have more than two vectors and you're asked to calculate or to get the resultant. How do you do that? The very simple thing. All right. Now, let's take a look at this question. If you know you are not subscribed, please kindly subscribe. Now, calculate the resultant of 5 coplanar forces. In this case, you're giving 5 forces of values. The values are given here acting on an object at O. Now, this is the central object at O. All right. Now, the first force, as you can see there, is 10, 12. The 12 is at an angle of 50. You have 20 at an angle of 40 to the horizontal. Have another one, 16, and we have this as 15. Now, this question may look confusing. I'm going to demystify it, give you a very simple way to solve questions like this. Now, the rules I'm going to use is inside trigonometry, but I'm not going to bother you with that. I'm going to give you a simple way to get it. First, what you need to know is this: the 4 quadrant, right? You have something like this. This is all. This is sine, tan, cosine. All right. Here, all of them is positive. Here is sine is positive, tan is positive, and cosine is positive. Now, take note. Once you know this, and two things. This kind of vector, what you need to do is you resolve it into 2 parts or into 2 perpendicular parts, the horizontal and what the vertical component. So, how do you get the horizontal component? Horizontal component, you can watch my video on resolution of vector. Horizontal component is gotten using this formula. No horizontal in a graph is x, right? So using this, v cos theta. Now horizontal is cos, all right? While vertical is vy, y axis, all right? Is v sine theta. Now once you know this, you've gotten this. Now let's now solve. Let's now resolve this whole vector into what? The horizontal component first. Then we'll now resolve this whole vector into what? The vertical component. Once you get the horizontal and the vertical component, you can now calculate the resultant and you get the angle, and that's all. So let's now do the needful. First, let's resolve it into what? The horizontal component. Remember this. All right, I'm starting from here. So I'll be resolving it from here, starting from here, going this direction and to the last point. All right, so please take note of that. Now, let's start. Let's do for the horizontal, Vx. Now, let's take the first one. You know we are starting from here, right? So, and horizontal is actually cos theta, right? So we now have 10. Is there any angle here? No. Cos 0, because it's exactly on the horizontal side. Now the next one is 12 plus, just be adding it, 12 cos to the horizontal, to this line. We are starting from here, remember? All right, so this line is 50, right? Cos 50. Next, this is the first. Now here to here is 90, right? And here is 40. So what will be this place? This whole place is 90. So if you remove 40 from 90, here is actually what? 50. And if this place is 50 and here is 90, 90 plus 50 is actually 140. How did I get that? I'm looking for this angle from this place to this place. That is, this whole place is actually what? 140, because I'm adding the 90 here to what? The 50 here. So 90 here plus this 50 here. How did I get this 50 here again? Is this whole place is 90, right? And they said this place is 40. So this remaining place will be what? 50. So this 90 plus this 50 is 140. So I'll now put 20 cos 140. Remember, I'm using that quadrant. Here is all, here is sine, tan, and what? Cosine. All right, so I'm starting from this place. I'll be resolving all towards this place. It's a very short method. Now, what is the next one? This one. So here is 90. This place is another 90. And this place is another 90. So here is 90. Here is 90. And here is 90. So we have 390. So 90 plus 90 plus 90. What do we have? 270. So this angle, that is from here to the end here. Here. From here to this place. Remember, this place is our reference point. So from here to this point, it's actually what? 270. So we now have plus 16 cos 270. Okay. Then the last force that we have here is actually 15. Now, from here to here is 270, right? Now, if we want to resolve this last one, 30 plus that 270, because we will now be looking from here to this place. Remember, this place is our starting point. This is all. Is our starting point. So from here to this point now is 270 plus this 30 is 300. So we now have 15 cos 300. 15 cos 300. So we've gotten our answer. So how, just take your calculator and press. I have 10 cos 0. What do you have? Vx is equals to 10 plus 12 cos 50. What do you have? 12 cos 50. You have 7.7. Let me just put it to 2 decimal places, okay? Then you can decide to put 10.00. You still have the same thing, okay? Plus, now we've done this one, The next one is 20 cos 140. 20 cos 140. You have negative 15. So I'll have to remove this sign. Because minus, you have negative 15. So minus or negative sign times positive times this positive sign. What do you have? You have a negative sign. So you now have minus 15.32. So the next one we have is 16 cos 270. So we have 16 cos 270. What do you have? Plus 0. Right? Now the last one, what we have here is 15 cos 300. So let's do that. 15 cos 300. What do you have? Have plus 7.5. So now let's just add. If you add this thing together, what will you get? So let me quickly do it with my calculator. 10 plus 7.71 minus 15.32. 0 is nothing plus 7.5. What is our final answer? Our final answer here is what? 9.89. Now this is plus 9.89, right? I have my reason for adding the plus at the end. We'll get to know that. Now let's result this. So this answer is actually the horizontal component. What about the vertical component? Vy. So we'll just follow the same pattern. Here we have 10. Instead of cos, what will you be doing? Sine 0 plus, now here is 12. The angle is 50. So 12 sine 50. Now remember, you can go and watch my video on resolution of what vector. I told you that, I even said it at the beginning of the video. Y is V sine theta. Y x, or the horizontal component, is V what? Cos theta. So wherever I'm having cos here, I'll just change it to what? Sine. And that's just the shortcut. So I'll just quickly redo it. 20 sine 140 plus 16 sine 270. Because it's the same angle. Look at this. This 16. All the angle to this point is still 270. So then the last one, 15 sine 300. Now, you now use your calculator. Vy is equal to, so you put your 10 sine 0, what do you have? 10 sine 0, you have 0 plus 12 sine 50, what do you have? 9.1, 9.19, okay. 20 sine 140, 20 sine 140, half plus 12.86 approximately, okay. 16 sine 270, 16 sine 270. Now you now have minus 16. Now remember, you're supposed to have plus here. But because your answer, if you check this with your calculator, you have negative 16 or minus 16. So the minus negative sign times the positive sign, if you use negative sign to multiply the positive sign, what will you get? You now have here now minus 16. So this times this, what will it give you? To now give you minus. Negative times positive will give you what? Negative. So you now have negative what? Or minus 16. So the last one, 15 sine 300. So you now have 15 sine 300. What do you have? You now have negative also, because if you have negative, you use negative times this positive, you also have negative. You have negative 12.99, which is approximately 13. Okay, so what will be our answer here? So our answer will be 0 plus 9.19 plus 12.1, 2, 3, 4, 5. Okay, 12.86 minus 16 minus 13. What is our final answer? So our final answer here is actually negative 6.95. So this is our vertical component. Now, back to our quadrant. In your normal graph, this side is actually positive vertical axis, and this side is negative what? Vertical axis. This side is positive horizontal axis, this side is negative horizontal axis. So let's now look at our value. The horizontal axis is actually what? Positive, right? So we can draw our line this way. Okay, why the vertical axis is negative, which means it's down this way. So I can eventually, let me clean this place. So remember, because our horizontal is positive, go to your graph, take a look at it. You realize that this side is positive for the horizontal, this side is negative. Why this side is positive for the vertical and this side is negative? So because your vertical is negative, because your vertical component that you calculated is negative, you take it downward. Because your horizontal is positive, you take it this way. So that's the reason for this graph. Now let's clean it and do our normal calculation so that we can get the resultant. So we now have it like this. Here is actually 9.89 and here is minus 6.95. Now the resultant, as usual, will be like this. And if it's like this is our angle. Now this one, you can redraw it like this. So here is actually 6.95. Let me write it with minus 6.9. Now, using your normal Pythagoras theory, you can put arrow resultant. Here, let's put it as A and here as what? B. So now have arrow square is equals to what? A square plus what? B square. So arrow square is equals to what is A? Minus 6.95 square plus 9.89 what? Square. So look for the square and 6.95 square. What will it give you? Give you arrow square is equal to 48.3 plus, what will this one give you? 9.89 square. You have 97.8. Now, let's take it this way. If you add these two together, you now have arrow square is equal to 97.8 plus 48.3. You have 146.1. Now, in order to get arrow, the value for arrow, what will you do? Look for the square root of both sides. So we now look for square, and this 1461 point square root of this and square root of this. So this square will cancel out this. Now have arrow is equal to, now look for the square root of this. So the square root of 146.1. What will be our answer? Answer is actually 12.1 approximately. So Newton. So here, the resultant here is actually 12.1. Now, eventually, you can look, you have, this noise is too much for the video. Please. Eventually, you can look for this angle. So let's put this place as theta. How will you look for this? It is actually very simple. You can use your normal trigonometry. How would I do that? I can use cos theta is equal to what? Adjacent all over what? Hypotenuse. If you do that, you just get your answer. So let me clean this place. Let me clean this place and let me clean this place. So we now have cos. You know you can use a normal SOHCAHTOA. So this is S is standing for sine. This is opposite all over hypotenuse. This is standing for cos. Adjacent. This is adjacent all over hypotenuse. This is standing for a tan, opposite all over adjacent. So for this place, for me to look for this angle, I'll just use, let me just use adjacent, which is this all over what? Hypotenuse. So I'll use cos theta is equal to adjacent. So cos theta is equal to what? Adjacent all over what? Hypotenuse. So what is your adjacent? 9.89. What is your hypotenuse? 12.1. And cos theta is equal to, if you do your normal division, you get 0.81. Okay? Or approximately 0. Let me just 0.8174. So you can look for the inverse. That means the theta. Inverse of what? This. So you can always use your calculator to do that. So 0.8174. What is my answer? My answer is actually what? 35.1 or approximately 35.2 degrees. So my angle here is actually what? 35.2 what degrees. So this is the answer. The resultant is what? And the angle is that. So that is it.